Richard.
Yes.
Great jam.
That was great. Yeah.
Thank you.
Yeah. You want to break down that patch for us? Tell us what you're doing there.
Yeah, I could break it down.
Cool.
It was, like most modular stuff, it's a bunch of very simple things, sort of switching between them then. So it starts with the kick drum, and the kick drum is our low-pass gate module, and we're just pinging it with a trigger. When we do that, it self-oscillates for a moment as the Vactral does its thing, and it just gives this huge low end. The output of that runs through a low-pass filter just to roll off some of the snap from when you ping the low-pass gates, and it gets that really fantastic kick drum sound. So that's always sort of the core of any time I'm doing something with a beat like this. That's my kick drum of choice. The bass line itself was played by the Voltage Laboratory, and the Voltage Laboratory has this amazing thing. We have this wave folder in it, and then we call it a warp circuit, and what that allows us to do is fold waves that we've gone through this before. It folds waves that you couldn't previously fold. So like saw waves, for example, don't fold very well, but you run it through this circuit and it just gets this huge gnarly sound. So if you mess with the folder while you're in this warp mode with a saw wave, you end up with, I call it the precision bass through an Ampeg head sound. And that's exactly what it sounds like. So that was the bass line in the track. And then the rest of the sort of random percussion was the double helix oscillator. And that was sort of some bloopy percussion because that has the low pass gate S in the wave folder circuit in as well. So that's all you have to do is hit it with the trigger and you get that nice percussive sounds out of it. And then I did a stream a couple weeks ago where I keep looking over here because that's where the system is. I did a stream a couple weeks ago where I put our old digital oscillators in there. So I left one in for today. It's the Symbiotic Waves, and the Symbiotic Waves was doing this sort of metallic. It wasn't really a hi-hat, somewhere in a muted hi-hat, muted ride sound. That was the Symbiotic Waves, and I'm just hitting the effects with it with just a random so that the effects would change periodically and give it sort of a liveliness to it. And I think that's the majority of the patch. The big droning synth sound was the SV1, the SV1B. That was the sort of repeating drone that sort of washed over you and kept things going. That's a 2-oscillator synth sound from the SV1B. So the nice thing about having like the Voltage Lab and the SV1B in a modular system is, I'm always going to want a bass line, and I'm always going to want some sort of lead or some sort of other synth sound. And they're in there and they're ready to go, and I don't have to think about it too much. And I know this stuff so well, I can patch that stuff up. I just sort of patch it up as I'm thinking about the next thing I'm working on. And then the driving all of it was the percussion sequencer module. So that was what did all the beats. And I was essentially just flipping through different patterns to go from section to section as I tweaked along the way through. But it's everything in here is Pittsburgh stuff, and I thought it sounded pretty good.
Nice. HR Chair asks, how hard is it for you to do a 10-minute set instead of a 3-hour set?
It's almost impossible, I would say. To the point where I was setting up earlier today and I was working on it. And I thought, well, if I only have to do 10 minutes, I should really try a little bit. Because usually I do live streams. For those of you who are not familiar, I do live streams on Pittsburgh Modular YouTube channel a couple days a week. And I call them patch labs, and they really last sort of the length of a patch. And as you guys know, the work in modular, you sort of patch it up and you get nothing for a while. And then it starts to take form and you're like, oh, this is starting to get good. And then it's really good for a while and you're really digging it. But then after a while, the patch kind of starts to fall apart. And so I do these patch labs and I just sort of ride it out the whole way from the beginning until the end. And when it's over, like, well, the patch is over and the patch lab's over, and you kind of go from there. So some of those live streams get extremely long. But doing 10 minutes, I felt an obligation to make it good or interesting the entire time through. So I did spend the afternoon trying to write a song and come up with something that I thought was maybe a little bit different than I do on my channel. So I've been listening to a lot of early 80s and industrial music recently, a lot of Front 242 and that type of stuff. So I wanted to sort of pay homage to those guys tonight. That's where I went.
Nice.
Cool.
So you also had, his was funny, Rich, because I'm a longtime fan of your modules. And so as you were naming stuff, I was like, oh yeah, that one. Oh yeah, that one. Oh, that's my favorite. Maybe that's my favorite. And I saw you had 2 game systems in there, but it's funny. I was like, wait, did Rich make a game system XL or something, or is that 2 game systems in there?
It's 2 game systems. That's a module that I absolutely love because it's the perfect sort of clock utility and the perfect beat utility. It's all So I have 2 of them in here, and they're each doing. One of them's doing a clock divider, and the clock divider in the game system was great because it was a 2-dimensional clock divider. So not only did it divide the clock by 1, 2, 3, 4, all the way up to 8, but then each one of those could be offset. So you could say divide by 4, but then offset. So you're hitting it on the 3 instead of on the 1 every 4. So you could do some really interesting stuff like that. So that's sort of always running in my system as a clock divider. And then the second one sort of always is running as the random burst generator, where it's generating random patterns based on the CV that's coming in.
That's the mode I use game system in a lot. Like just as random bursts. And plus I like the way the interface looks when it does that.
I like it. It.
And you mentioned the DNA symbiotic waves, and I look over there because I'm looking at it, right? That is, so for those that don't know, I feel like there's a long history with myself and Pittsburgh Modular because on BBoyTechReport.com, the first modular system or module at all, Eurorack, anything that I reviewed was a Pittsburgh Modular system. And in that system, there was the DNA symbiotic waves, and I knew that was a module that I was going to have when I actually built my own system, and I have it to this day. It's because it's so versatile, right? But you all don't make it anymore. Is it out of It's out of rotation?
Oh, that's been out of production now for 5 years, maybe 4 or 5 years. I think that module was canceled before your review went up. If I remember correctly. What happened was, and we had designed a second digital oscillator as well that was a wavetable oscillator. We called it the double helix. And what happened was, at the time, we were sort of finishing up the development of that, and the symbiotic waves was up for renewal and production. Our current engineer, Michael Johnson, really stepped up and really became a part of Pittsburgh Modular. Michael Johnson is an analog genius. The guy, and his ideas are fantastic, and the way he solves problems, I'm in awe. So the opportunity for me as a designer to work with Michael very closely and more often was more important to me than the digital stuff. So I thought, well, because we're a tiny company and we have limited funds and limited resources all around, it seemed crazy to spend any resources on digital stuff when I knew the future was me and Michael Johnson working together and focusing on analog, because that's where our passion was and that's really where our heart is. So we canceled the double helix digital oscillator, and the symbiotic waves, we decided not to do another run at that point and focus solely on working with Michael. And I think what you can see is that the fruits of the labor are way worth it with what we're getting, the interesting sounds we're getting out of like the Voltage Research Laboratory and the double helix oscillator, some of this analog stuff that Michael's really had a huge say in. It's absolutely the right decision that we made. It is a bummer because the symbiotic waves is a great oscillator. I hadn't up until a couple weeks ago. I hadn't played with it in a couple years, and it's in my system now, and it's probably going to stay there for a while because it has such a sound, and I think it complements our analog stuff so well because it adds a little bit of that crispness and that harshness that you're going to get out of the symbiotic waves. That I've been digging it.
Yeah, that's what's always been dope about symbiotic waves, because, and I remember when you introduced it, you said we wanted to make a digital oscillator that just does digital well. And at the time, there was this whole thing where people were like, is it digital or analog? If it's not analog, I don't, you know what I mean? And that's what I always thought it did. It just does digital so well and it's so versatile. And I also concur because the double helix is in my case, and when I did a video like right away on it, and at least 5 to 5 or 7 people hit me up within a week. Like, I just bought that thing because it's such a great sort of fat and round sound that you can get out of it with that low pass gate in there. It's just a dope choice. Is that the same circuit from your low pass gate module, or is it slightly different?
No, the low pass gate module that I'm using, that I used for the kick drum here tonight, is an actual Vactral circuit. It's a circuit that was sort of a redesign of the original Buchla low pass gates. The low pass gate that's in the double helix, and actually all of the low pass gate-esque circuits that we use now going forward as of 3 or 4 years, we call them dynamic VCAs, or dynamic filters. And the reason we changed it from calling them low pass gates is we re-engineered around the Vactral, so there's no actual Vactral in our low pass gate circuits anymore. And what that allowed us to do is, what happened was, I sort of tasked Michael with, I said, wouldn't it be great if we just made an analog emulation of a low pass gate of a Vactral? That sounds really hard. I said, yeah, you could do it though, right? I'll try it. But it took him about 5 or 6 months, and I got a phone call late one night. It's like, Rick, I did it. Listen to this. And it sounds amazing. You can't tell the difference. It emulates, his analog circuit emulates the Vactral perfectly. Now we're about 3 generations in on that circuit, and what we can do is, not only does it sound just like a low pass gate, but we also have very wide control over the Vactral. The problem with the low pass gate, and everybody that has one knows this, is that sometimes you get one and it has a real short pluck to it, and sometimes you get one and it has a real long pluck to it, because Vactrals, the tolerances are all over the place. So some of them ring for a long time, and some of them only ring for a couple seconds, or for a couple milliseconds. What we're able to do now, because have an analog emulation of this, is we can dial in the length. So with a knob, you can set it. You want a real short percussive sound, or you want a real long tubby ring, you can do that too. And with the Voltage Lab, we've now voltage controlled that. So we've now sort of finished this circuit that we've been working on for about 4 years, and it's amazing. It sounds amazing. It does everything we want it to do. I think it sounds better than what we set out to emulate at this point. It's really taken on a life of its own, which is why we've sort of stopped calling them low pass gates, because they've really evolved into something on their own. So we call them dynamic VCAs. The dynamic filter module was the first iteration of this. That's the circuit that's in the double helix. And what it does is it adds so much versatility to these modules, that because everyone loves that sound, that sort of plucked low pass gate sound, but now you can dial it in. It's way, way nicer.
Nice.
That would be a cool envelope module, actually, where it's just like that circuit with the trigger input and you output the envelope. Yeah.
The problem with doing that, and I agree with you, and actually on the dynamic filter, there is an output for the envelope. And the reason we put it there is if you attach that to, say, a VCA, it doesn't really do anything. And a lot of people said, well, why would you have this? It doesn't, because the curve matches the curve of what the Vactral expects and not what a VCA expects. So if you plug a VCA in, the CV of VCA, it just sounds like a snap or a click. But if you take that output of the dynamic filter and patch that into the CV input of an actual low pass gate, the low pass gate then takes on the curve that you dial in with the dynamic filter, and you then can take a low pass gate that does have a Vactral and change the response curve of that as well. And that's what that was there for. And it does some really, really exciting sounds with that. But granted, a limited user base for something like that, but it sounds really good.
Nice.
This.
Oh,
throw
dope.
that up there. Yeah.
VRL is just awesome. I built my whole modular system around it.
Nice.
You know what's interesting is I brought Ali, the architect, up to your booth at no, it was somebody else, and Ali, the architect, and I went up there, but there was someone else that was talking to me about getting into modular, and I was like, you should just get a system, like a small system, something that you can kind of really work with and really learn. It was funny when I took him up and showed him the VRL. Somebody at your booth, I don't remember if it was you or someone else, they were like, "This is what you want him to get as his first system." So tell us a little bit about like it looks. I mean, it's a small form factor. It's not a huge system, but it's a very different system. Tell us a little bit about that sort of dynamic of this footprint that kind of packs a lot of punch and a lot of tricks up its sleeve that way.
Yeah, the size the size it is, which is 48 HP, and the reason it's 48 HP for the Voltage Lab module is that's what the SV1 was. The SV1 is our most successful product by a long shot. We've sold way more than those than anything else. So we thought, well, and we have the black box for the SV1 as well. So I thought, well, I'm going to design another synthesizer. Let's make it the same size because that size people seem to like it, and it can fit in a black box, which means we only have to stock one case for both things, which for a small company is a good thing. But what happened was, as I started developing, as I started to work with Michael, and we really started to get our hands in there and decide and mold and shape what this thing was going to be. We were looking at synthesizers like the Buchla Music Easel and that West Coast, some of the Serge stuff I was really doing a lot of research on. And that's where our heart was at the moment. So as we kept looking at this 48 HP saying, okay, we can squeeze one more thing in here, right? We can put one more circuit in here. And I wanted it to be a pair. I wanted everything to be a pair. So as you went through it, I wanted 2 oscillators and I wanted 2 some type of envelope and 2 some type of dynamics. And as I did that, it got tight very fast, but I didn't want it to grow at all. So I just said, well, let's be very efficient about this and let's serve the needs of this instrument. If we think of it like an instrument and not like a Eurorack module, let's serve the needs of this instrument. So all the decisions we made on whether features are kept or features were dropped, whether there was jacks for a particular function or whether we left the jacks out, was all, does it serve the needs of this as a synthesizer, not this as a Eurorack module? And because we only had so much space to work with, it had to be focused on, okay, it has to be an instrument first. The fact that it's Eurorack is great, but that was secondary always. So once we had an interesting, what I thought was a great feature set down, it worked and it fit in the panel and it looked good and it was fun to play with. Like, you know what? Wouldn't this be really good if it had an analog delay in it too? So we redesigned it again and we shifted everything over, made everything a little bit tighter so we could squeeze that analog delay in there, and it made all the difference because the analog delay really brings the instrument to life. It gives it character and it gives it depth that I think it wouldn't have had any other way. But it's that from design to what ultimately became the instrument, the process of doing it was such a wonderful experience. This is the first instrument that I would say is probably 50% Michael Johnson and 50% me. And most of the instruments leading up to that were, obviously Michael Johnson did a lot of work, but it was sort of me presenting ideas saying, hey, here's what I want to do. How can we do this? And we would do it that way. This instrument was more like, well, let's work together and let's come up with something that really showcases what we're both interested in and what we can both do. Michael from an electronic standpoint and me from a design standpoint. And so for that reason, this instrument means so much to me. The fact that the world seems to enjoy it as well, and it sort of has a lot of special meaning for other people as well, is great. But for me, it's such a collaborative instrument that it's fun to use. And I have one sitting right on the shelf behind me here. You can see it right behind the Perfect Circuit logo. And I pull it down and use it all the time. There's something about it that just makes me smile. And I think people that have purchased one and people that that were lucky enough to get in on the Kickstarter, and then lucky enough to get one through Perfect Circuit, and the few retailers that had them while they were available, I think definitely enjoy them.
Nice. Yeah, really dope instrument. And that was something that you all were talking about before we went on. And I don't know, I mean, maybe people know, because I know you've done your rounds and did your promotions and stuff for it. It's the touch plate, the keyboard on it. Like the fact that it's like 10 steps and 10 touch plates. What's this kind of story behind that piece?
The touch controller was interesting because we'd done a capacitive touch keyboard in the past that had a traditional keyboard style interface, and it was quantized, and it was fun. But I thought, if we're going to do something that's more West Coast, let's really embrace this. So the touch controller that I ended up designing it has 10 touch plates, and the reason it has 10 is it splits into 2 groups, 5 and 5. And the reason I chose 5 is it was sort of an homage to Don Buchla's circuit and the 5-step sequencer that was in the music easel. It just seems like such an interesting number, because it pulls people out of that 4/4 rigid timing that they're used to doing, and it makes them think a little bit differently. Now, the way the touch controller works, you're not limited in any way by 5 and 5 or 10, because if you tap in a sequence, you just play in a sequence, and you can play it in any order up to 64 steps. So it's not really limiting, but it pushes your mind maybe in a direction that it wouldn't have gone in normally. And hopefully it pushes you down a creative path that maybe you hadn't thought about taking a peek in. The touch controller is an interesting module because it's one that on the surface, because it only has 3 buttons, it has the 10 touch plates, and then it has 2 rows of knobs. It looks very simple, but it is extremely deep. And it was designed for me. I do, well, until recently, I do soundtracks to silent films at a local theater here. And I needed a controller that I could use in the dark, that I could just feel, and I would know exactly what it was going to do. There was no modes. It wasn't doing anything crazy. I could see and feel, and it would just let me know. So this was designed for that. And it really, it has sequencers. You can play it monophonically. You can play it sort of duophonically, but it's designed to have a ton of depth that's instantaneous feedback for the performer.
There's a question too in the chat. I just put it up on the screen there. What Serge modules inspired you? When you mentioned that you were talking about some of the inspiration that was behind this.
The Serge stuff that we were looking at, and it wasn't really specific modules or specific bits that Serge did, but it was more of his philosophy and how everything is sort of there. And Serge, if you think of Buchla as Buchla's giving you a finished set of tools to produce music with, it feels like Serge took it one step back and said, well, let's give them, instead of giving the finished set of tools, let's break those tools apart and give them the pieces to build those tools. And that's what really inspired me, was the idea that, okay, let's break some of these tools apart and give you ways to interact with them that maybe is a little more granular than a finished piece. And obviously his dual slope generator is a key component of West Coast synthesis. Everyone has sort of done their version of it, and now in the Voltage Lab, we've kind of done our version of what we feel like a modern dual slope generator would be. So that's where the Serge angle comes in on that.
Cool.
Nice.
Let's see if there's any other questions in the chat. I'm kind of all positive feedback there about it.
Is the what is it? The Lifeforms analog delay, is that the same delay that's in the VRL, or is that a different one?
It's
or similar. It's just broken out into a module of its own.
Yeah, the analog delay unit, the Lifeforms analog delay unit module, is the same exact clone from the delay that's in the Voltage Lab. It was such a fun circuit. Mm-hmm. And actually, before we put it in the Voltage Lab, we prototyped it as a standalone delay. And it just made sense. Right? We had already done all the work to make it its own little module, and it sounded so good that we thought, okay, here's a 6 HP analog delay, does a third of a second of really clean delay. People might dig this.
Can you guys see that?
Mhm.
My screen is different, just so people can in the chat can see that.
And those are those already out there? Are they starting to ship soon?
Those are out there. They've been out there now for quite a while, I think.
Okay, good.
Yeah, we had some here, I know.
And I suspect you may still, but that module is absolutely still available, and it sounds great. We are working on finishing up 2 new modules, new ESC that should start shipping. Our supply chain got a little slowed down, but should start shipping in the next 3 or 4 or 5 weeks. We have the SV1B, which is the second version of our SV1 synthesizer voice. We call it the SV1B because B seems like 2, but it's really the same exact synthesizer. It just incorporates all the mods and sort of updates we've done to it over the years. And we have a black panel, so SV1B, the B could stand for black. The story behind it, but really I named it SV1B sort of as an homage to the Korg MS2000B. I don't know if you remember that synth.
Totally remember that.
When that synth came out, and the panel was black on that synth. When it came out, I had the MS2000, and I saw the blue one, and I saw that a couple years or a year later they came out with the black version. They called it the B, and I'm like, how awesome is that they changed nothing about it? They put a black panel on it, and they called the 2000B. I thought that was just fantastic. Years later, I learned that no, they had actually added an XLR input for the mic, and they had tweaked a couple things. But for years, I just thought that was the best thing in the world. They just change the color, give it a new name. There you go. So, in honor of that, we called the SV1 the SV1B, and it does have a black panel. It's the same design language that we have on the Voltage Lab.
Nice.
So we have that. That should be coming out as soon as we can get them, 3 or 4 weeks or so. And then after that, we have the Cascading delay network, which is the other thing that we showed at NAMM this year. And that is...
Oh, yeah, that's an incredible delay.
It's a really interesting...
What's the size of that one?
I can't remember. It's big. The SV1B is 48. The Cascading delay network, I want to say, is 28. Okay. Would be my... I'm looking at it, trying to remember. It's been a long time since I thought about that. I think it's 28, but it's big. And what it is it's 4 delays that are behind the scenes, tied together in various different ways. So you can sort of rewire the insides of it by cycling through the different modes with a button. It's not using our analog circuit. We tried the first version of it. We actually prototyped it with our analog delay unit, and the problem we had was when you stack up 8 bucket brigade chips, it was so noisy. It was just uncontrollable. We couldn't get rid of the noise. It's just 2 chips. You can do it, but with 8 it didn't work. So we switched to the PT2399, which is it's an old digital karaoke reverb chip. Mm-hmm. And the nice thing is, they're not too expensive, and they have a real interesting sound to them. And they were trying to design a digital BBD clone. How well they succeeded, I don't know. But it has a characteristic all of its own. There's a ton of guitar pedals that use this chip. And I think it sounds really good. And Michael then sort of did his magic on it and did tweak it in a way to make it sound as analog as possible, but we didn't want to lose this great characteristics that it already had. So we're not trying to pretend that it's an analog clone. It's not. It's PT2399s, but there's 4 of them in there. And what makes it really interesting is that gave us more time. With the analog chips, we could get about a third of a second using 2 BBDs. With these chips that we're using now, we can get 0.6, 0.7, 0.8 tenths of a second per chip. And on the back of the Cascading delay network, you can set the delay time for each one of the channels up to, I think it's 0.7 or 0.8 tenths of a second. 8 seconds per chip. Now, at that point, they sound like garbage, but if that's what you're doing, that's great. You can set them from anywhere, I think, from 50 milliseconds up to 8 seconds. But we set them in about 0.8 of a second, and they sound really good there. And the way they work together is the cascading part of it is you can chain them together so that they become one long delay where you then have your tap-ins. So each one becomes a tap-in for a larger delay network. And then there's one long feedback path. So it acts and sounds for all intents and purposes as a single delay. But with all those tap-ins, you get that great multi-tap sound. And then we have ways that you can pull stereo left and rights out of it and get some really, really interesting effects. That's just one of many, many modes that this thing has. There's 2 CVNs that you can assign to any of or all of them. So it is a really, really interesting module. If you haven't seen some of the demos, we did a ton of demos on it at NAMM, so check those out. We're going to have a ton of information coming out in the next weeks or so. Once it's closer to available, we'll do a formal introduction and we'll have the typical ridiculous videos that we do for it. Now, and I'll do a long, super boring walkthrough in what each mode does, but it sounds really good. And it's really unique in the Eurorack world this time. Actually, I don't think anyone's even done a pedal in this way. So it lives in its own little world, and it has a sound that can be anywhere from a multi-tap delay or 4 individual delays to sort of reverby soundscape type vibe to it as well, and anywhere in between.
Have you tried just cranking up the feedback and using it as a weird oscillator yet? Or
of course, the way it works is because there's 4, you can, and there's different modes. So there's 4. There's different modes where one it's all 4 are one delay unit, or you can do the next mode is where you have 3 together and 1 independent, or you can do 2 together and 2 together, or you can do all 4 independent. Now, I started, once I had that done, I'm like, okay, this sounds great, but I wanted more feedback. So another mode, then each one has an alternative mode where I enable all the feedback paths. So can think of one long delay unit with all 4 in there, but then each one has different feedback paths. So the 4th delay can feed back to the 3rd and can feed back to the 1st and can feed back to the 2nd. And the 3rd one can feed back to the 2nd, feed back to the 1st. And think of all these delay feedback paths happening all at the same time. It can get wildly noisy really, really fast. But if you keep them in control, you get these burbling, sort of shimmering sounds. And that's where you can get those beautiful reverb tones out of it.
That sounds cool.
Yeah, it sounds really cool.
There's a question in the chat. I'm going to just pop it up here so everyone else can
Great
kind
question.
of back on it. Mm-hmm. So it looks like you've moved to designing synthesis ecosystems and then splitting out individual modules for those units. In your opinion, is this a more cohesive approach to modular development? And then versus, just kind of toss us up there, it's a compound question, versus say the one-by-one approach of module development that eventually adds up to a full system.
For Michael and I, the way we design, it makes a lot of sense for us to design a complete instrument. As a designer, it's a lot more fulfilling to design a complete instrument that I can say, here, I can hand an artist, here's a synthesizer. Go. So for me, that's go. So for me, that's way more interesting as a designer. But I understand that not everyone that wants an analog delay unit or wants a complex oscillator wants to have the entire voltage lab, say, in their system. So it makes sense for me then to go through and say, okay, here's just the delay, or here's just the function generators, or here's just the complex oscillator. What that also does is it allows me to revisit those and say, okay, the complex oscillator, for example, there was a ton of features that we had to pull out because there simply wasn't room, or there was room, but it didn't service the voltage research lab itself. It was extra, and it wouldn't have made sense within the context of the instrument. But if we're doing a Eurorack module now and we're expanding on that, we can say, okay, it doesn't have to, it's not servicing any particular instrument. So we can add these extra features that maybe in the voltage lab didn't make any sense to have in there, but in the context of a large Eurorack system, of course you want these extra features added in. So now we can go in and say, okay, for the complex oscillator, let's get huge with this thing. And let's really, really expand on the ideas that we started working on with the voltage lab. The complex oscillator that I've designed based on the voltage lab, it's gotten a little out of control. It's the voltage lab itself, for those who aren't familiar, is 48 HP. The oscillator I've designed for it now, I think, is 32. So it allows me to sort of throw everything at it, throw the kitchen sink at it, and do something that within the context of oscillators is really interesting, or within the context of a delay is really interesting. So it allows me to expand on the ideas, and that's how Michael and I approach it.
I think that's a pretty dope approach. Just in the sense, I like what you're saying about, when you're designing an instrument, you're really designing what's going to be best for the instrument. And, so many times in Eurorack, just outside of a system like that, so many times in Eurorack, we all get caught up in that module, this module, that module, this module. You can look up and have a case that doesn't have a cohesive sort of instrument look, feel, workflow, or whatever it might be. So I think it's dope that you approach designing in that fashion, and then you can expand on the whole thing to kind of break things out and give those extras and stuff. Because I mean, it just speaks a lot to how you're really thinking in a very cohesive manner, and then but you can really give it to the nerds out there amongst us that really want it. Like, if you want something like this, here it is with all of the CV and outs and knobs and sliders and stuff that you want, that be broken out into a Eurorack. It's a dope way to approach the design.
It makes sense. If the voltage lab had every feature that we could have put in every section, it would have been twice as big, and it would have been unapproachable. It would have been so dense and so complex that it would have failed as an instrument. So it's sort of two different mindsets. You're either designing an instrument, in which case each feature has to serve that instrument, or it can't be in there. It's just it's extra, and it's only going to cause confusion, or it's only going to cause frustration for the artist. And we don't want that. We want a clean set of tools to present to the artist. Now, as synthesizers, when we design these synth voices, they're not meant to have every single feature. We want to present them with a curated set of tools and say, here is an instrument. And it is. A curated set of tools is the words we use at the shop, because it's not everything, but it's the things that make sense within context. Eurorack modules are a completely different world. People expect everything to have everything. Or they expect it, the sizes have to make sense. So if you're doing an oscillator that's 6 HP, of course it's going to have, you can only do, it's probably going to be a meat and potatoes oscillator, because you can't do much more in 6 HP. But if, you're going to try to sell someone a 32 HP oscillator, it better be really, really exciting and do some really, really interesting, innovative things. And working with Michael and I, that's sort of what we're interested in now, is pushing the boundaries of what you can do with analog and sort of making interesting things. So that's the direction we're going in on the Eurorack side.
I think now that you mentioned this new giant oscillator, people are curious to hear more about it. If you're willing to talk about it.
That was my next question. I popped it up there.
The crazy huge oscillator.
Yotis he's a regular in my live streams, and he's actually seen pictures of the oscillator. So I think he's taunting me, but that's fine. If you can think of take the complex oscillator in the voltage lab and explode it and say, what else could we have in there? How can we expand on this? If you sort of take that and then take the template was the double helix, which I think is an unbelievable oscillator. It has a life of its own and a sound of its own. And it brought something to the table that was interesting. I love the idea of complex oscillators, but I have no interest in doing clones of the Buchla 259. There's a lot of great sounding Buchla 259 clones out there already. The world didn't need one from us. It was unnecessary. So we look at these and we say the double helix is a great example of this. So I think I'd rather talk about that maybe than this other thing, because the double helix exists and it's tangible. So if you look at the Buchla 259, it has a primary oscillator and a secondary oscillator, a modulation oscillator, if you will. And then it has different ways that those oscillators can interact. When we said, okay, and then it has a VCA bus to modulate the modulation, so to speak. And that's sort of the heart of that oscillator. We said, okay, well, but what makes that interesting? What do people like about it? Let's expand on that. And one of the things is the idea of that modulation index. And so we said, okay, well, what if we had a modulation bus system at the bottom where you could then have two modulations? And we had our secondary oscillator as one of the modulation sources, and then we added another LFO because we're going to do two. We needed a second source, so we built in a second LFO, and that was cool.
Look at her.
And we said, okay,
for people to see.
and so on the bottom of that, you can see is the modulation bus, and it's brilliant in how it works, and it makes it fun because you have these two VCAs driving two buses. And if you start to think about it and you start to really dissect it, you have access to one of those VCAs as a VCA at all times. So what we've sort of done is given a West Coast synth voice in the disguise of this double helix oscillator, because the contour section over there, the top section is a wave folder. And right below that, we have our dynamic VCA built in. And it's the second generation of that based on the dynamic filter. So you have this low pass gate circuit, you have a wave folder, you have two VCAs, you have an LFO, you have two full range oscillators in there. It's a lot of oscillator. And then the modulation bus, the way you can interact with everything, there's a lot going on in there. And that's what I mean by, if you're going to create these large modules for Eurorack, you have to justify every HP, because HP is expensive and people want more modules. So to say, okay, I'm going to take up, a third of your row with just an oscillator, it has to have a reason to exist. So if you look at that oscillator, you're really getting two oscillators, an LFO, a noise source, a random, a wave folder, and a low pass gate, and then two VCAs. It's a tremendous amount of stuff. And then because we're putting all that in one spot, we can fine tune the wave folder so that it sounds brilliant being hit by the oscillator. And the low pass gate is fine tuned to accept the voltages coming off of that wave folder. So everything sounds better because it's integrated together. That was a lot of talking.
That was well done.
That was a lot of great information.
I use the LFO for other things all the time, and what I mean, interpatching or just hitting the low pass gate and letting that ring out. It's a lot of versatility. It creates such a wide array of sounds. It still surprises me to this day, and I've had it for years now.
Yeah, it's the double helix is one of my favorites, and the reason it's called the double helix is originally we had designed a digital double helix module, and I loved that name. The module we ended up not
say that when we were talking about the DNA symbiotic wave.
it was the DNA double helix, which makes sense. It was a wavetable oscillator, but we ended up going sort of setting that aside and focusing on analog. But when came back to the oscillator, I was like, and if we're going to do a complex style oscillator with two oscillators, it's got to be the double helix. It makes sense, and I love the name, and the layout is very similar as well. It's because I put a lot of energy in the other thing. I said, well, let's use a lot of that towards this thing, and I think the decision was great because the double helix analog oscillators, it sounds amazing. I'm very, very, very proud of it.
It should be. It's a great oscillator, it really is.
I just want to call out to the chat to see if anybody had any other questions, any additional questions out there.
Anything you want to know about me at all? Anything at all? Or anything about any of our modules? I'll talk about any of our modules as well. If you have any weird questions about a weird module, I could probably answer it.
Thank you too for coming on and joining us on the chat too, Richard. It was really nice to virtually meet you and have a chance to talk to you here about the modules.
Yeah, it was nice to meet you as well, and it's a lot of fun. I love talking about this stuff. So I do live streams on the Pittsburgh Modular YouTube channel a lot of, and some of them I do interviews, or a lot of it's just, I call them patch labs, but they just sort of devolve into hanging out with people in the chat and talking about synthesizers, because that's what I love to do. So it's nice to have a community and a group of people that you can sort of just hang out and talk about the things you love. It's cool.
Your buddies in the chat right now, patch lab tonight.
You know what? I think there will be, because I put this patch together, and I think tonight I will slowly.
You got a second call for it. Patch lab now.
Patch lab now. Get off here. Go
Get
do a
on
patch
it.
lab.
When this is over, I will have to move the cameras a little bit for the patch lab, but yeah, I suspect there will be one.
Cool. There is actually a question in the chat. I'll just put it up really quick. They'd like to hear about the primary oscillator.
Oh yeah, the primary oscillator. And another one of my favorites in my system that I use tonight. I have 2 primary oscillators in there. The primary oscillator was designed to be a companion to the double helix, but it's by no means a stripped down analog oscillator. We wanted to do something, again, really interesting and try to push analog and the idea of what you could do with an oscillator forward. So we packed, and that's another module, we just packed so much in there. So it can function as a standard oscillator. You know, it has all your basic geometric shapes available to you. But in addition to that, we have what we call the fragment circuit, where it is essentially a second voltage controlled oscillator inside there, controlling an analog sample and hold that allows you to do that sort of bit crushing sample and hold trick built in. We have a wave folder in there, and there's also what else? I'm trying to remember everything that's in there. There's so much. The blade wave is in there as well, and the blade wave, what that is it's a modulatable saw wave. So you can go from saw to a double frequency modulated saw, or anywhere in the between with the slider. So all of that built into one oscillator. We call it the primary oscillator because it really would be the focus and the main oscillator if that was, the largest or the most important oscillator in your system. I think it sounds really, really good. And again, we tried to just throw as much in there as we absolutely could, because to me, the idea of the signal path of a saw wave into a filter, into a VCA, into an output, we kind of did that already. We've done the vanilla modules and the meat and potato modules in the past, and we have the SV1, which is an amazing sort of East Coast synth voice. So why it doesn't make sense for us to sort of retread what we've done in the past or what we already have available with the SV1. So when we started working on the primary oscillator, we wanted something smaller, obviously, because we had the double helix, which is a large oscillator, but we also didn't want it to just be a meat and potatoes oscillator like we've done in the past with like the waveforms or with our oscillator module. So again, we said, okay, if we're going to take 12 HP, let's really make it worth it for people to use 12 HP for an oscillator. And the sounds you get out of it, it ends up with its own voice. It's really, really unique. I don't know what else I can say about it.
They're happy with your response. That's their response. Yeah. There is a question about the touchpad before we move towards the end. Is there a way to record the y-axis per step?
Yes. Yes, there is. Cool. And if you watch my video, the really long, boring video about the touch controller, it walks you through how to do that. But yeah, absolutely. The y-axis is when you're programming in your sequence, the y-axis is remembered, and you can draw it in as well. Yes, you can.
All right.
And obviously, the nice thing about doing these full synthesizers as well, instead of individual Eurorack modules all the time, is that we can do really nice manuals. So, the Voltage Research Laboratory, I think it has 6 manuals associated with it. If you go to the Voltage Research Laboratory page and scroll all the way down to the bottom, I think there's 6 manuals for it. A total of like 150, 200 pages. I spent months working on that stuff. But there's a great manual for the touch, and the reason I bring that up, there's a great manual for the touch controller on there that you can go through and just go through the patches. And
I like that you can see the patches on there. And
yeah.
I've been reading through it. So,
and that's the nice thing about doing an instrument is you can provide a manual because an instrument has its own context. Where a module, it's difficult to do a manual for a module because there's no context. I don't know what you're patching into it. I don't know what you're going out of it into. So it's difficult to do a full-blown manual. It's very easy to say, here's what the functions are and here's how each one of them works, but it's hard to give any context to that. With the manual, the Voltage Research Laboratory manual is a great example of this. It was really important that people read it because there's a lot to that instrument. So what I thought I could do to get people interested is the first thing you do when you open it is like, okay, let's patch up a soundtrack that you can listen to while you read through the manual. So the first thing in the manual is a soundtrack to the manual, and you have to patch it up. And it's sort of an auto-running, sort of generative patch, but it's a great way to get people just patching it up. And they don't really need to, as they're patching it, they don't need to understand what they're doing. But what that does then is it takes the fear away from touching it, and it says, okay, it's okay that I can do this because I'm following step by step. And now once that's sort of running, your sort of fear is maybe down a little bit and you're not as afraid of it as an instrument. And then as you work your way through the manual, it sort of opens you up to it. That was the kind of idea behind it. And that's why, doing these instruments is great because it does get that barrier of entry lower because Eurorack can be intimidating to people. I know I answered emails almost every day, people saying, oh, I don't know where to get in, or I'm not sure how to start. So, I always recommend, the SV1Bs or the SV1's a great way to get in because it's a familiar interface. If you're familiar with East Coast synthesis, it's a familiar style of synthesis, and you don't need patch cables right away. But what you do then is, oh, what if I patch this into this? That was harmless. Actually, that sounds really good. What if I try it this way? And it's a very natural way to get into modular synthesis. And, so eventually everyone could work their way up, to where we are, where, you can sit down and you can patch a wall full of synths and get something musical out of it instead of staring at it going, I just
where do I start?
Yeah. And that's no fun at all. I want artists to embrace this stuff, but to do that, I have to give artists a pathway to there. So we spent a lot of time talking about that, a lot of time working on documentation manuals so that people can get it and enjoy it and make art with it, which is the goal.
Nice. Well, I've enjoyed them. They're very colorful too.
Well, thank you.
Yeah. Very inviting. No, seriously, I've read through them and it's like, oh, okay, like learning how to use the touch plate. So
that's an art to itself, though, right? The making a manual, because I gotta say, not everyone's manual.
No, that's what I'm saying. It's colorful.
There's some manuals you could walk away from, like, I'm frustrated now. I want to sell this thing.
Yep.
That doesn't help me at all. If you buy something and a week later you put it up on Reverb.
Yeah, so right.
It's in my best interest for you to keep whatever you purchase from me. But I spent for the Voltage Research Lab, those manuals took me 2 months to do, and they were a hard fought labor of love because the instrument itself means so much to me that I felt it was my obligation to present it properly to people. And because we had done the Kickstarter, I felt obligated to these people that had invested their money in me to give them an instrument that they would be able to embrace. So the documentation was a huge part of me feeling like I was holding up my end of the deal on that. And it worked out well because it does allow, now people that buy it from Perfect Circuit have this great documentation that they can also dig into.
Mm-hmm.
Yep.
Of course, you can't buy anymore, but
you go read the manual nonetheless.
Definitely check out the manual. It's a good manual.
That's right.
The videos you guys.
Oh, go ahead.
Oh, the videos. I was just going to say the videos that you guys did when for the voltage research lab. I really appreciated those too. They were really creative and interesting and really cool.
I agree.
Those were so much fun to do. Those little 1-minute teaser videos. The reason we started doing that because we were leading up to Super Booth when we were going to announce the instrument and announce the Kickstarter, and we got the first batch of panels in, and they were all wrong. So we had to send them back. So we didn't have any panels. We had nothing to show. And we didn't actually have, the instrument didn't have panels until 2 days before we left for Super Booth. But we wanted to we wanted to build some hype and we wanted to tease it. So I thought, well, what if we do these little 1-minute videos and don't show the instrument at all? Because, well, we couldn't, even if we wanted to. But it solved a really interesting problem. And it turned out to be a brilliant idea, because what it did was, it forced people to judge the instrument on how it sounds before they were going to judge it on what it looked like. Or, because immediately when you see a new synthesizer out, the first thing you do is you go, oh, it doesn't have this, it doesn't have this, it doesn't have this, it doesn't have this. This, you couldn't do that. All you could do is say, that sounds bonkers, or that sounds, oh, that's interesting, that sounds different. You had to judge it on that before then you could sort of feature pick it. So it turned out that it worked out really well. And I love doing those little 1-minute videos. I still do them to this day. I try to do a couple a week because they're super fun.
The thing that I thought was also pretty interesting about those videos is because the way you all pushed it with what you were saying in it, it was kind of like it's this synth, this instrument that sounds natural. It kind of blends with the environment and this whole natural thing that you all were pushing. And as you were saying it, you find yourself looking at the video like, it does sound like that. It looks, what they're showing is what it sounds like. And then it kind of gave you a whole different connotation of it as an instrument. Then to finally see it, it was like actually a huge reveal. It was a dope way to approach that.
Yeah, we sort of built this idea of organic analog synthesis around it. And at first it kind of sound, for people first hearing it, it kind of sounds like, oh, they just came up with a dumb marketing term to try to hype this thing. But the idea of organic analog synthesis is really what our whole design focus is. We want to push analog synthesis into more organic, more real sounding worlds, because we feel like that's an area that has never been explored from an engineering side. There's so much left to do in analog that we feel like we're competing with digital, because digital sounds amazing now. You can do a ton with digital that that you can't do with analog. So we thought, if we have to compete with these amazing sounding digital instruments, we need to really push the limits of what analog can do and do things that you couldn't do before. So the idea of organic analog, and if you listen to the instrument, it does sound that way. That was 100% conscious design decisions from the day we started working on the oscillator to when we finished the analog delay, which was the last part of it that we had worked on. So every step of the way, the idea of adding more organic sound to it was built in there. And it became frustrating then, as I started to do these little videos, I started to realize that, the English language has so few words to describe sound. If you try to think of different ways to describe an analog sound, well, what do you sound? It sounds warm. It sounds organic. It sounds natural. What other words can you come up with? And anybody in the chat, if you come up with good words, let me know, because I will use them in the videos. I've run out of words. I wish the English language was a little more eloquent with this stuff, because it's hard to say. The SV1 sounds so much different than the Voltage Lab, but there's no words to describe how. You just kind of have to hear it, and you have to hope people can interpret it. So the idea of organic analog synthesis is our way to try to circumvent that and say, this is its own little world.
If you have one more moment for there's a question in the chat. It may have been answered but I think if you want to weigh in, the question was, is there any way to use the wave folder circuit on the VRL with outside audio?
No, the wave folder circuit in the Voltage Lab is hardwired to the selected output of the primary oscillator. There's no way to dive in. You would have to mod it to do that. And that's an example of, I was talking about earlier, how every feature was designed to serve the instrument as a whole. And that's a good example of that, because if I had the external, if you could attach the wave folder externally through another instrument, well, the Voltage Lab only has so many sources of audio. It didn't make sense within the context of the Voltage Lab to have a way to access that wave folder externally. Now, when you do the larger expanded modules, that's a perfect example, again, of absolutely you need to be able to get to that wave folder externally, just like you can in the double helix. You can patch in a third-party oscillator or anything into it and run it through the wave folder, run it through the low-pass gate. So that's what I was talking about earlier. You know, the features in the Voltage Lab serve the Voltage Lab, where when we break out and do these expanded modules, you can solve those type of problems. Yeah. Sorry, we ignored you twice, but hopefully that answers your question.
Sorry about that.
Someone said you can. Oh, someone said you could use architecture or dancing phrases to describe synthesis, or maybe I was thinking also cooking. There's lots of food adjectives with you.
Oh, that gives me some good ideas.
Nice.
Next week, watch for 1 minute videos next week. They're going to be fantastic.
There was one other question. I don't know if you have a moment. I want to scroll back. Somebody was asking about the sequencer, and I'm trying to find it. I thought it was a good question. Sorry.
If you type the question, maybe type it again so we can find it.
It was by off 711.
Okay.
Let me see if I can.
Oh yeah. Also, someone just said don't go down the wine snobbery description route for your.
No. I'm more of a beer guy.
There you go.
Man, I'm sorry. Like it was a question about the sequencer, and I apologize for not being able to.
I think he said we answered it. Thanks.
Oh, okay.
Good.
All right.
That's efficient.
I like to make sure that everyone that's listening in and making comments, that they get their questions in. This is a great opportunity to participate. So.
Yeah, that's what makes these online shows so fantastic, is because everyone in the chat is just as part of the show as we are, and it really gives everyone a sense of community. We can all hang out together and all talk about things that we love.
Yeah.
All right. So, how do you feel about jamming us out of the hour now?
I could do that. I could jam you out.
All right.
Cool.
Well, I just want to say thank you to everyone for listening in, and yeah, the next chat we actually have, or live stream we have going on, is on May 4th. May the force be with you. It's about the Akai Force, right,
Nice.
Corey?
Yes.
Right. Like that punt. I'm a Star Wars fan. I'm sure there are others out there. So
the force is always with me, son.
Yep.
Yeah, I'm looking forward to it. You guys make sure you come back and check it out. We got some good stuff that's going to happen on that night. And,
we have some performances, and you're going to walk us through some good tips, right, B-Boy? Tips?
Sure.
Yeah. All right. Okay, so thank you. And Richard, I'm going to give it to you.
Okay, cool. I did want to say,
Sure.
for everyone watching, if you're not subscribed to my YouTube channel, go check it out, Pittsburgh Modular. I'll probably do a live stream tonight, sort of destroying the patch that I'm about to play now. And I do videos, patch labs, and talk show kind of stuff 3 or 4 days a week. So if you want to check it out, check it out. Otherwise, I'm going to play some music now. Thanks, guys. Thanks a lot for tuning in.
Thanks, Rich. It's always good talking to you, man.
Thank you.